number 5 on this sheet because it's kind of another good example. 266 all the way up to 300. The reason why we made 2 zeros here and not just we did 270, like a lot of students wanted to do 270 like that. Well, 270 is harder to deal with in your head. If you make it 270 times 30 and take off your zeros, well, I can do this in my head. That's going to be 60 and 21. It's going to be 81. But most students can't, and it slows them down too much. So 27 is not a good number when 300 sure makes it very easy. Cross off those zeros, you got 9 and 3 digits here. And because this is a lot larger and this is somewhat smaller, well, your answer might be kind of close. It's going to be, the student might think it's a little bit larger or a little bit smaller than 9,000. But even the fact that they've got 9,000 in mind tells them that if they come up with some over a number here that's not correct, they can go back and check their work. And when one is larger and one smaller, that gets a little tougher because you're really thinking about the amount of change that's different. So for example, to go to 266, that means I'm adding 34 to that number, but it'd be 34 times 34. 34 times 34 times bigger than the original problem. And that would be like in excess of 900 times, because 30 times 30 would be 900. So this answer would be a lot different by adding 34, and that's why it's so much bigger, and that's why it's more likely that it's quite a bit larger than it's smaller than the other one. Okay, similar is this one right here. Again, dropping this down, losing 26. That's 26 47s that this has been changed. 24 40. Yeah, I'm sorry, it is 26 20 because you've taken away 26 of 26 times 47 to make it 100. So this one has gotten way smaller, and this one's gotten a little bit bigger. So that means most likely here your answer is going to be smaller because how much size difference change there was as you made that front end estimation. And if you see here, really it's like you're doing front end estimation on the first one and then just using traditional rounding on the second one. And again, that's okay. The purpose of estimating is to know if you're close enough or not. Last one down here on the bottom, number 10, is just an example I like to give. Students often, they go, okay, I want to do front end estimation, I'm going to make it 2,000, but that means you're taking off 426 49s. So I tell students to look at this and say, 24 is pretty close to 25, and that's like a quarter. 4 25s is 100, for example. So 24 at 500 is pretty nice. And then if you made it 50, you're only changing that by a little bit. Take off those zeros, 5 25s. Well, again, 4 25s is 100, and one more 25 would be 125, and 3 zeros. And that number is so large anyway that you have definitely a sense for how big this is. Even if you're off by a few thousand, compared to the size of the answer, that's not much to be off by. So again, this is meant to help parents understand what I'm looking for with how students should estimate when they are preparing to multiply. And it is officially called, or can be called, front-end estimation for multiplication of algorithms. And I hope it helps. Thanks.